Hi, today we'll be continuing with the features of the microservices. In the first video, we already discussed how we can create independent loosely coupled microservices. They are independently deployable, scaling and technology, independently deployable. Why we prefer the microservices? Because they are independent and self-contained. As per the domain-driven model, we can actually segregate the functionality into different atomic services, and then we can actually consume, we can invoke them and wherever we require. Just listen to this video carefully. I'll explain the key features of this microservices. Basically, they are independent. I already explained. You take a e-commerce supply chain management application, for example. We generally create an order. When we logged into any e-commerce website, what we do first, we will look for the item descriptions or required items things, and then we will select them. We will add those items to the cart, and then we will check out those orders, right? Then order will be placed. So here, what are the different functionalities? Different functionalities are searching the different items. So search functionality. We require a separate service as well as placing an order. When you create an order, we need an order service as well. When order is created, we have to pay the amount, right? For that, we need a payment service also. When payment is successfully done, then we have to generate a alert notification. We need a notification service. So that way, we require to define different microservices. They are self-contained services. They're always self-contained services, and they're independent. So services have minimal dependencies, right? So working on the services is a very simple thing. We don't need to bother about very complex system. If we take a complex application, we will design and develop all the code in a single module, right? It is a single application. So it will be the complex application, because when we create all the modules in single project, it will lead to the bigger size of the project as well as the complexity also. When maintaining the application also, it leads to the complexity. And organized around the business capabilities, services mapped to specific business functionalities. You see, API first communication. Services communicate always via well-defined APIs. So independently deployable, you can deploy this, so we can actually maintain separate services, separate teams for developing separate services. Scalability is also easy, as I told you, right? So let's say when people are ordering, the order service will take the load, but when they pay the amount, of payment service will be done. All the people may not place an order. They will not pay the amount. Only few people, but most of the people, they will look search for the items, and they will add the items for the cart. Then the load for the search service and cart service will be very high. Then as the demand increases, then we need to increase the uh, number of instances for serving that load also. So it is a very important thing, always remember. So for individual services, we can scale up and scale down depending on the requirement. So fault isolation and resiliency, you see, we can also build the fault tolerance, isolation, resilience, small and autonomous teams. It is very automation. Automation is also, one of the good thing. It relies heavily on the automation testing. When microservices architecture came into the picture, CI/CD, separate, DevOps. This system has been implemented. CI/CD, DevOps, separate methodology, separate, practice has been introduced only because of microservices architecture. Okay, now I want to explain. Um, I want to explain using Spring Boot. You see, I want to explain this. Before that, I want to tell you one thing. Every day, I'm going to make some videos on the technology from here after onwards, because I want to avoid this rowdyism and gundaism. So I'm going to make a videos definitely in YouTube and technology oriented, because I always wanted to be chief technology officer. I never wanted to be CEO of any company or anything. My goal is to become, CTO, chief technology officer. I always like the technology, new trends, how the technology trend is moving towards the globalization, how the inventions are being happened, how people are become inventing so many technology, new technologies. Always, we are getting a lot of technology trends every day. Nowadays, software has been completely changed with the introduction of the AI. Yet the people require the developers, the support engineers, maintainers, and DevOps, the people require them. Anyhow, you see it. I'm not interested in one kind of technology. I'm interested in lot of technologies, not only in one technology. I never interested in one technology. I'm interested in lot of technologies. So I always try to explore them. I'm always interested in them. I like them, and I would like to make the videos in those things also. Let me explain a few details. I already explained service discovery. I also made a video on the service discovery. I also explained the code, a little bit of code snippet, how we can actually build a service discovery using a two annotation at the rate enable service, service registry and client. You can see. So now we can see API gateway. For configuration management, we use the Spring Cloud config. In one of the videos, I explained how we can do the external configuration management using Spring Cloud configuration. So these things we can do it, right. This is a very important thing. And API gateway here, I'm going to explain the API gateway along with the code. So API gateway Spring Boot example. Okay, I will just give a brief about it. I will not go in depth in this. Just see here. I'm going to use Spring Cloud Starter Gateway. It is very required, and the YAML file I have it. And we can also create a .properties file, but also we can also use an application.yaml file. You see here, the name of the service is API Gateway Service. We can see application Spring application name and Cloud Gateway routes. We can specify the routes here. What we are doing here, because we will get a request for the service gateway, so as the entry point, right. Now based on the service request, based on the service endpoint URL, we have to reroute that request to the particular service. For example, you see service 1 hyphen route is the unique ID for the first service, and we have to give the specifically required endpoint URL, localhost, the service running on the port 8001. And the predicates is the will specify the path, because here is the endpoint URL match, because client is going to invoke particular service using a slash service one, then immediately it will reroute this particular request to the particular URI, right. The local host, the service URI that is running on the port 8001. So if the client invokes with the slash service tool, the predicate matches, then immediately it will invoke another endpoint URL using localhost colon 8002. You see here both service 1 and service 2, they are configured, their routing mechanism is configured inside the application gateway, and you need to start the application gateway. When you run the application gateway, you see when the client invokes the slash service 1 8080 slash service 1, it will route to 8001 endpoint URL. The same way for service 2 as well. So this way you can actually configure the routing mechanism inside the API gateway. You can actually configure filters. So you can also integrate the service discovery also. I know that I can explain you later, but you see, you can actually integrate the service. That is not there in this example, but remember, integrate the service registries with Eureka, dynamically discover the microservice location, avoiding the hard-coded URLs. Security also you can, both to JWT, validating the JWTs, security, I'll explain the security, how we will do. Generally, we will create a authorization server and authentication server. Register basically the task server. What we will do, we will actually configure the task server here. As soon as the request comes here, the request actually, as per the filter, it will goes to the task server. Task server will generate JWT token, and that JWT token will be propagated to the further consecutive downstream services. So that way we can also configure the security. That is another huge concept. We can discuss that tomorrow. If required, I will explain what is the security, how we can establish what to Spring Boot security and JWT tokens, how we can use that, how we can establish a communication among the many microservices. I will explain that. Rate limiting is also one of the concepts. You see, number of requests can be processed per second, and the volume, controlling the volume of requests to prevent the system overload. Sometimes the people can make cause overload to the system, or they can also cause by creating this huge load, creating this huge load, and then make the system hang. That way it will not respond to any other request further. That is the problem. So to avoid these DDoS attacks and these load attacks, we can actually configure the rate limiting. This is also one of the good example. Okay, now you can see another thing is, I hope you understood the API gateway. We have used the Spring Cloud gateway, the provider. We also have a configuration management, Spring Cloud. What is this? I'll explain this one. You can see here, let me explain you this Spring Cloud config server exam. Okay, this one I already explained, but again, I just want to show you the little bit high. See here. First thing is we need to create the config server. You can see here. And next thing is the config client, right? Okay. Um, you can check out on my another video. There you can see the code also. For the server, you need to use @enable config server annotation. That way, you are going to mark the service as a config server, and you need to specify your repository details here. Remote repository detail, GitHub, Bitbucket, or any other SVN repository, whatever it is. You need to specify all those details and also create the config client. And you see here, we can actually mark any config client using a Spring Cloud starter config, and that way, application.properties file is there, and then you can actually inject all these values. Create a REST controller that uses. You can see this later, but I don't want to go into deeper here. But I hope you understood what happens here. Every client that will first talk to the cloud config server, where that cloud config server will fetch the details from the repository, and it will provide all these details to all the client services that are going to talk to this config server. So dynamically this will happen. That way we can externalize or centralize the configuration properties. That way we can manage it. That is why we have mentioned here externalized and centralized management of configuration properties across all the services. So resilience 4J, okay, it is part of the circuit breaker design pattern of fault tolerance. Um, okay, let me explain what is the resilient 4J. Also here, I'm going to explain that as well. Resilient 4J Spring Boot example. Okay. Okay, now you see here example. We need a code. Okay. Okay, so we need to get the code right. Reason for second Spring Boot example. My internet is not giving. Okay, so, okay, now you see. In this first, what we have to do, we have to add the dependencies. Starter web dependency, circuit breaker resilience 4J. You see, we have added a new dependency here. Yeah, actuators, for monitoring health and all, micrometer for. We need a resilience 4J micrometers dependency also. Okay, but here it is mentioned these two are optional if you want to monitor the health and indicator. But primarily we have to use circuit breaker resilience 4J starter dependency. Okay, now what we are going to do? You see here in the application YAML file, what you have to do, you have to specify the number of properties. Sliding window size 10, number of calls to record the outcome. Okay. Uh, the what we are doing here, number of calls to record the let me permitted number of calls in off open state, number of test calls is, so generally circuit breaker mechanism is like so, open close and off, three phases will be there. um, you see here, wait duration in the open state, time the circuit stays open. Okay, if a circuit stays open, then it means there is no, you know, there is some problem with the invocation of other service. You are not getting output, right? So then, what it will do? It will keep on sending the, it will keep on invoke the other service. Okay. Then as soon as if another service is active, then circuit will be closed, I think, right? Circuit will be closed, and that way it can actually communicate properly without any issue. So automatic transition from open to off, open enabled. So these are all the states. I don't want to explain deep into here, but you see, we need to specify the properties. I'll explain you the concept here. The circuit breaker is, you are going to invoke a particular service, right? Here you see in the circuit breaker, we have written a fallback method. Inside this, I'm going to call localhost 09090 slash API slash data, right? Using a REST template. So whenever this particular endpoint is not working, it may be down because of some issue, then what happens? It will not. It may return the service something like uh, server is down, or sometimes it may go to hanging state because of server is not working, right? So there are so many possibilities, so many issues are there. To avoid that, what we are going to do here, whenever this particular service is not working, immediately we have to inform the client saying that there is some issue with the invocation of other service, it is not working, right? We need to render the proper response time, render proper details saying that this particular service is unavailable. That is why we need to create a fallback method with the proper data where the client can understand it. That is why you can see fallback method must have the same signature as the original method. That is why I mentioned a fallback method equal fallback retrieve data. You can see here we are able to retrieve it. And create controller, you can see we are going to create a controller, create a REST controller to expose an endpoint that uses service. You can see at the rate REST controller, right? Circuit breaker controller, and you can see here I created a constructor here, and then I injected the external API service object, this dot service equal to service. And what I'm doing here at the rate get mapping slash API slash data. And then you see here, we are actually, we created a method, right? A get data inside that service dot retrieve data from external server. We are actually calling this service method, and it will go here, basically retrieve data from external service method. It will be invoked. Inside that, we are calling another endpoint using REST template. REST template is one of the class generally used to invoke for establishing a communication, for invoking RESTful API, REST calls, for that we use the REST template. That way, whenever the other service is not working, the endpoint is down, other service is down because of some issue, then immediately the fallback method will get executed, returning a proper response, proper error message to the client. That way, we can build a resilient service. Resilient means in case something is broken, something is failed, something is down because of some issues, then the calling service, the calling client should be notified with the proper error message. That is called a resilient way of building a service. Resilient way of, proper way of communicating the error messages or exception messages. This is called resilient way of building service. That is why we use circuit breaker design pattern and resilience 4J. Okay. Now I hope you understood what it is. Now you can see here, and I hope thanks for listening. I'll discuss further.